plexiglass, a tough, transparent plastic of many uses, perfected in the fiery crucible of war. Light in weight, high in impact strength, resistant to weathering and chemicals, superior in optical quality, dimensional stability, and crystal clear transparency, proved on far-flung battlefronts in bomber noses, cockpit enclosures, gun turrets, navigators' astrodomes, gunners' sighting panels, and in many other parts under severe service conditions. This is Plexiglass 2, one of the most fascinating and beautiful of the new plastic materials created by chemical science. With its permanent clarity, sparkling brilliance, warm touch, strength, and ability to pipe light. Ready to bring new beauty and comfort to your home and add charm to your peacetime living. Just as there are many kinds of woods and metals, so there are many kinds of plastics. Most of them are familiar in everyday life, in factories, offices, and homes throughout the land. But in this great variety of plastics, there is one outstanding in crystal clear transparency, sparkling brilliance, and stability against weathering and aging, and that is plexiglass. But just what is plexiglass? To the chemist, this material is a synthetic resin, called an acrylic. To the manufacturer, it is a material of superior quality which can be fabricated or molded into almost any desired shape. To others, plexiglass is a material of gem-like beauty and sturdy utility, either as a brilliant transparent plastic or as a colored or translucent material. Plexiglass comes basically from crude petroleum, which, as the result of a complicated chemical synthesis, is transformed into a clear, colorless liquid known as monomer. When heated, this clear liquid gradually thickens. If it is poured into a mold and heated further, it will finally harden into a solid plastic which can be fabricated. By a similar reaction, the same monomer can be converted to a powder for molding. Both sheets and powder are now being dramatically applied to peacetime living in hundreds of beautiful and useful ways. The service plexiglass rendered in aircraft provides striking evidence of the permanence and strength of this transparent acrylic plastic. This permanence, strength, colorless transparency, and resistance to chemicals, weather, and age are the result of more than 40 years of active research by the Rohm Haas company. Plexiglass was developed in Rohm Haas laboratories, first brought to commercial production in Rohm Haas plants. In the transition from war to peace, plexiglass has found wide application in many fields, with new uses being conceived by designers and engineers almost daily. Some users value plexiglass because of its excellent optical properties, its perfect transparency. Others take advantage of its dimensional stability, resistance to weathering, and lightness of weight. In many applications, the permanence of its electrical insulating qualities is the first consideration. Others, like bus door windows, require properties like high impact strength, shatter resistance, and flexibility. Even though plexiglass appears to be as fragile as ordinary glass, in the hands of an expert, it can easily be worked into an endless variety of beautiful and useful objects. Using ordinary wood or metalworking tools, plexiglass sheets can be sawed, carved, drilled, routed, or turned on a lathe. Plexiglass sheets can be cemented or heat welded into strong, colorless joints. Since plexiglass is a thermoplastic, sheets of the material can easily be formed when heated to moderate temperatures like those attained in ordinary ovens. Heated, it is pliable as rubber and can be tied in a knot, stretched, or formed into almost any desired shape. Cooled, it stays rigidly in its new form and has the ability to resist severe impact without breaking. Forming the large three-dimensional transparent plexiglass sections, like the familiar bomber noses, gun turrets, and astrodomes, involves improved techniques in fabrication, methods developed by Rohm and Haas. By using air pressure or vacuum, plexiglass can be formed to various shapes determined by the shape of the chamber opening, from a hemisphere made by vacuum forming, or a windshield section made by snapback forming, to such articles as protective housings, boxes, lighting globes, and aircraft canopies, all formed exactly to size and free from objectionable optical distortion. The use of air pressure in still another way permits the economical making of various shapes. Simply by blowing air into a shape, much as a glassblower works, results in a home for fish like this, or a shallow water helmet like this. So versatile is plexiglass, and so wonderfully easy to work with, that no matter what the field of application, there is almost no limit to what can be done with it. The same versatility is found in plexiglass molding powders. In giant molding presses, the powder is heated, softened, and forced into a mold of the desired form. Molding is used when a large number of identical parts are required. Notice that each is fully shaped as it comes from the mold, requiring no further finishing. Many people compare plexiglass with ordinary silicate glass. Yet this new plastic differs from glass in many ways. Its flexibility, shatter resistance, and strength give plexiglass special advantages when best use is made of these properties. In the Rohm and Haas laboratories, tests are constantly made, tests that result in sound knowledge of these properties, tests that indicate how plexiglass can be used for best results. For example, how strong is it? These laboratory technicians find out how tough plexiglass is, how it will stand up under severe service, how it will withstand repeated impact, compression stresses, outdoor exposure, and accelerated weathering. And when it comes to cold weather, plexiglass can take it under severe conditions. Here in a specially designed cold room, laboratory engineers produce stratospheric temperatures of 67 degrees below zero, or a man-made 200-mile-an-hour tornado, to make sure plexiglass can really stand the gaff. Here, too, are other devices for flexing and to simulate vibrations of many kinds. Other machines test optical properties. And still others measure its electrical insulating properties. The resistance of plexiglass to the action of chemicals comes under never-ending scrutiny. And because it resists the action of most chemicals, it is used in many industrial applications. Day in and day out, week after week, every month of every year, these complete laboratory testing facilities reveal information which helps solve specific problems in the design of plexiglass products of every kind and description.
Formed and cooled plexiglass, as we have seen, stays rigidly in its new shape, but the material has one fascinating eccentricity. When heated again, it remembers its original shape and returns to it. This is called plastic memory. Let's take a look and see how well this memory works when it is put to a test. We'll begin with this plexiglass cube. In the oven, the cube is heated to a temperature of 260 degrees Fahrenheit. Then, in this pliable form, the hot cube is compressed into the shape of a disc. In this unnatural shape, the material is under stress. As long as the disc is kept cool, it retains its pressed shape. Now, heat is again applied, and the camera shows the effect of this plastic memory. As the disc becomes heated, the stresses are relaxed. Allowing the plexiglass to return to its earlier shape. Memory complete. Practical application of this plastic oddity? Misformed articles may be reheated and formed again without loss of material. As transparent as optical glass, plexiglass transmits every color of the spectrum with 92% efficiency. Because of this crystal clarity, when light enters one polished edge, plexiglass conducts it to the other edge efficiently. By repeated reflection between polished surfaces, light can be piped even through curved plexiglass, just as you see here. For this reason, plexiglass is used for medical instruments which conduct light, but not the heat of light, directly to the field of examination. Since light escapes wherever the surface is broken by sanding, machining, or carving, parts of these instruments are so treated to deliver light where it is needed. In the same way, any design, sanded, scribed, or engraved on a flat sheet, glows when the sheet is lighted from one edge. As a single panel, such an edge-lighted sheet can be used as a decorative screen or partition, or as a patterned wall covering which gives off light, a radiant wall. With several edge-lighted sheets of plexiglass, each carrying a portion of the design, a three-dimensional picture may be produced. Here is truly a new art medium. Plexiglass is hard for a transparent plastic, as hard as copper or aluminum. Yet, it lends itself to delicate and intricate carving. Using drills and burrs, much like those a dentist uses, a vast array of interesting and exciting designs can be carved into plexiglass. So that they seem to be floating in the depths of this crystal clear material. Plexiglass can be struck a hard blow without breaking. When struck violently, it may break, but into large, dull-edged pieces. Thin sheets are flexible, and even thicker sheets possess a resilience which enables them to withstand blows which would easily shatter ordinary glass. This safety feature finds application in many ways, from machine guards to displays where this strength serves to special advantage. Since plexiglass transmits X-rays, accurately fitting splints formed from sheets permit the making of an X-ray plate of knitting bone fractures. This material, too, lends its advantages to the making of light, durable, accurate contact lenses, ground to proper corrective curvature. As an engineering material, plexiglass serves in models of structural parts which, under polarized light, reveal strain patterns of various loads. And in another way, ink-proof drawing instruments of this material permit the draftsman a clear view of his work, do not discolor with age, and are not dangerously inflammable. The unusual optical properties of plexiglass have commanded the attention of those working in the realm of pure science. Its high transmission of ultraviolet and infrared radiation makes possible the use of plexiglass lenses in instruments used for study in these and the visible ranges of the spectrum. Plexiglass is a new and captivating material, a precious material to be cherished in your home as you cherish fine furniture, oriental rugs, hand-wrought silver. Properly cared for, it gives long and efficient service. Plexiglass should be washed simply with soap and warm water. Scouring compounds and cleaning fluids are unnecessary and often harmful. An occasional application of good furniture or automobile wax will provide a lustrous, protective surface. In industry, machine inspection windows, see-through parts, gauges and dial covers, and many other applications are made of plexiglass for its transparency, strength, and safety. Again, the transparency material lends its use for safety devices because the moving parts are always visible. And so, the applications of plexiglass are many and varied. This crystal clear plastic serves aviation, science, industry, and the home in ways without number. Nose sections, cockpit canopies, gun turrets, optical parts, medical instruments, splints, artificial eyes and teeth, lamp bases and shapes to brighten bases of other materials, lighting fixtures, colorful products of all kinds, almost invisible display fixtures, shaped to graceful curves or bent to appealing angles, transparent shelves, edge-lighted signs, and signs of three-dimensional quality, crystal clear or translucent. The crystal sparkle and liquid clarity of jewelry, carved bracelets, brooches, rings, and pins, and such things as decorative buttons, umbrella handles, handbag trim, canes, and chessmen, edge-lighted radio and automobile dials, nameplates, compacts and cosmetic containers, brushbacks and crystal-like ornaments, candy dishes, jewelry and cigarette boxes, bathroom fixtures, drafting instruments, tableware, salad bowls, coasters and trays, candlesticks, bookends, brush and comb sets, hand-carved figurines and statuettes. And there are hundreds and hundreds of others, all made by molders and fabricators all over the country, to whom Rohm Haas supplies cast sheets of a number of thicknesses and sizes and molding powders for compression and injection molding and extruding. In both its forms, sheets or molding powders, plexiglass is available not only as a clear, transparent substance, but also in a number of colors, both transparent and translucent, ranging from delicate tints to deep shades, which with care look their brilliant best today, tomorrow, or a year from now.
Looking ahead through plexiglass brings a glimpse into a wonderful tomorrow. A tomorrow where this crystal clear plastic turns its amazing characteristics to beautifying the home, to sweep away traditional styling in interior architecture. Planned by the Rohm Haas Company, pioneers and principal producers of acrylic plastics to show architects, designers, and homeowners just how plexiglass can add to the beauty and comfort of the home, this home of tomorrow, this dream suite, reveals new uses for plexiglass in walls, doors, and fixtures, glamorous effects in accessories and fittings, all inviting and warm to the touch, amazingly light in weight, yet strong and shatter resistant. Truly a dream suite of tomorrow, suggesting new comfort and enjoyment for today. To enclose the shower, a sheet of plexiglass is curved, engraved with an appropriate design, and lighted from one edge. The semicircular sliding door, also plexiglass, completes the enclosure. Plexiglass shelves treat a conventional idea with transparent beauty. The medicine cabinet door provides extra shelf space with a plexiglass warning label for the poison shelf. A dressing table of built-in efficiency and beauty. On one side, the pedestal swings open to reveal plexiglass trays for cosmetics, hose, and lingerie. The trays are crystal clear, formed with rounded corners for easy cleaning. A stack of drawers makes up the other pedestal with plexiglass liners to prevent snagging of lingerie. Radiant walls, brilliantly decorative in color, possible because plexiglass pipes light, provides soft, flattering illumination. The same lamps that give lustrous beauty to the radiant walls furnish light needed at the mirror. The lustrous and gem-like brilliance of plexiglass adds new interest to door handles, to a Lazy Susan hat tree, and to shoe racks. A graciously curved, transparent front wall of the bedroom or slumber wing lends an air of spaciousness to a room quite small. The sweeping transparency removes all feeling of confinement, and air conditioning becomes as easy and inexpensive as the operation of a refrigerator. Unusual in plastic artistry is this mural, painted in light, in color. The three-dimensional depth is produced by an assembly of engraved plexiglass sheets, edge-lighted to make a glow of restful beauty. Yes, in the home of tomorrow, there's plexiglass everywhere. Plexiglass partitions, plexiglass furniture, even plexiglass hats on plexiglass racks. Plexiglass all around for beauty, utility, and long life. Here is comfortable and practical living, built around the amazing properties of the most glamorous plastic of all, plexiglass. Here is great service in industry, built around the versatility of this war-famed plastic, plexiglass. Here, too, is an exciting challenge to the imagination and a vision of things to come when you are looking ahead through plexiglass.